Hello and welcome to Sparcon with Angie. On this channel, we explore different types of building envelope materials with insight into their price, durability, lead times, and just general performance through time. Today, we're going to be talking about the most advanced solid insulating material. Now, before we go any further, can you guess what it is without Googling it? If your answer is aerogel, you're spot on. Aerogel is the lightest solid material available with approximately 95% air by volume. Aerosol has an R value of 10, the highest by far among solid materials. For those that are unfamiliar with the term, R value is simply a material's thermal resistance. It's basically a measure of the ability of a material to resist the flow of heat through it. The higher the R value, the more insulating a material is. The most insulating substance in the world is a vacuum at an astounding 40 to 50 R value. It is followed by krypton gas, hydrochlorofluorocarbon or HCFC gas, and just simple air. With an R value of 10 for a 1-inch thickness, aerogel is 150% better than the next best insulator, the ISO board, and 250% better than the most commonly used insulation, which is fiberglass. Additionally, aerogel's insulating property comes entirely from air spaces, unlike that of the ISO board, whose voids contain HCFC or hydrochlorofluorocarbon gas. The HCFC gas is detrimental to the environment as it contributes to ozone depletion. The nano-sized aerogel particles can be of several materials, such as silica or silicon dioxide, and alumina or aluminum oxide. For insulation, silica aerogel is most commonly used. Because silica is essentially sand, aerogel is non-combustible, unlike the ISO board, which, being a polymer, is combustible. Aerogel was first used as an insulator in space shuttles for exploring the outer space. Aerogel insulation is available in flexible, high-strength blankets and strips, typically about 3/8 of an inch thick. It's also available in bulk as granules with mean particle diameter of approximately 0.5 millimeters. Being extremely expensive, aerogel insulation is limited in use to applications where conventional insulation cannot be used. Aerogel blankets are used to insulate undersea oil and gas pipes, for example. These pipes comprise an assembly of two concentric pipes in which the inner pipe carries oil or gas, and the insulation is contained in a space between the pipes. The use of conventional insulation would increase the diameter of the outer pipe so much that using aerogel is more economical. In buildings, the use of 2-inch wide or 3/8 of an inch thick aerogel strips has been promoted by one manufacturer to cover cold formed steel studs in order to reduce thermal bridging. The most successful application of aerogel in buildings is in the form of granular insulation to fill the cavities of insulating glass units used in windows and skylights. Because aerogel granules are translucent, aerogel filled insulated glass units provides light as well as insulation. A typical 1-inch thick insulated glass unit with aerogel filled cavity is rated at R5. As always, thank you so much for watching, and please join me on the next episode of Sparcon with Angie, the source for building envelope material insight.